Hi, my name is Muhammad Afzal. I'm part of Cisco Solution Engineering Group. I work as an engineering architect for validated solution. Today, I'm going to take a little bit deeper dive on the solutions that we discussed earlier with our teammates. I'm going to talk about Cisco infrastructures for containers, what Cisco is offering in terms of infrastructure-wise, what components are needed to build up on-prem data center to run containers, Docker Enterprise Edition for Cisco UCS solutions, and the Flexpod solution. I'm going to have a little bit discussion about the deployment workflow, how you set it up, stage it. These are the questions that you may have because how the things have been set up within the Cisco gears. That's what we are going to see. And how the Contiv has been integrated in those solutions. Then we're going to talk about the persistent storage for the Flexpod, and then the volume plugin in the very end. We have two solutions that are generally available. GA solutions, CVD is already out. Step-by-step guidance how to deploy on-prem data center for containers. They're enterprise ready. And scalable architecture, you can scale up, scale out with ease. I'm going to talk about a little bit more about UCS so that you can have a better understanding about the scalability factor of it. They're both jointly engineered with Docker, NetApp, and Cisco, and has been delivered by the partners, has been tested in our lab environment, validated, and then the whole CVD process, as you have already seen, goes through the enormous effort of bringing it to the market. That's the first solutions, Docker Enterprise Edition with UCS bare metal. In this architecture, we're talking about having two UCS blades. We're going to see more detailed topology in the next slides. Here I'm talking about what UCS offers you. As we have discussed before, UCS is purely stateless. I mean, there is nothing burned in any of the servers. Everything is in the service profiles. Literally, you can take any blade out or the C server out. You can put in another one, associate a service profile. You have a whole new server. And if you're using a shared storage, in that case, you can literally, as soon as you bind the service profile with the server, your boot policy also get attached to that server, and you can boot it up. You can have completely seamless transition from one hardware to another hardware. And you have storage profiles as well if you're setting up storage policies for your local disk. And V-NIC, which we can leverage, there's no shortage of V-NICs in UCS environment and VHBAs. So you can provision 256 V-NICs and VHBAs as you need grows, and then you can scale your environment with respect to the V-NICs. That's the capability of the WIC that offers you. This is the topology of the first solution. In this solution, we are using two Cisco UCS chassis, and each chassis has 5 blade servers in it. And that's how different role has been spread over different chassis. There are 3 controllers and 3 DTR nodes to provide you on-prem secure image repository, and 4 nodes has been dedicated for the worker nodes. In this architecture, you can in fact use all 10 servers for worker nodes if you would like to. If you want to just provision your containers within the worker nodes, you can make those changes within the Docker environment. And you can scale as you grow by adding more nodes, UCP worker nodes, and you can also scale your environment if you need more DTR nodes in order to make it more efficient as your needs grows. The second topology shows you how to set it up with the rack mount servers. In this solutions, we actually design it to coexist the controller and the DTR. Again, it's flexible enough to put the DTR and the controller in different rack mounts, and as many worker nodes can be added as you go. It's 10 gig end-to-end connectivity and 1 gig for management. Flexpod solution, which gives you stateful container applications, all the volumes are provisioned within the NetApp backend. It could be any NetApp filer, AFF 840 views. It could be ONTAP. And a volume plugin has been used. It's an FC connectivity, direct connect to the Fabric interconnect, giving you 8 gig of fiber channel connectivity. The network is 10 gig end-to-end. And it has no local disk. The boot disk is also coming from the backend, the filer. And it provides you end-to-end, highly available infrastructure. Here I'm going to talk about a little bit more in detail about the V-NIC, because this is something that we have leveraged a lot in both the solutions. Cisco V-NIC provide you dynamic failover from one fabric to another fabric if it has been configured in a way that is mapped to one fabric. And if one fabric fails, then it's dynamically failovers to the next fabric. So there's always a redundant path available. And the conversions is as fast as you can hardly miss a ping. And it's a hardware level failover. You can do things like by mapping, by assigning 2 V-NICs to a host, and you can do Linux bonding and things like that. But that's going to be software level failover, and here we are having a hardware level failover. So it's the choices that we leave up to the customer, whether they want to go with the Fabric A and Fabric B both and do Linux bonding. This is what we suggest if you want to go with V-NIC, just one V-NIC. And if you're leveraging other bonding technologies within Linux, like LACP mode or something, then go with the bond mapping with A and B and do the bonding. But if you're going with the failover type bonding in Linux, this is the better solution to go with. That's a high-level flow chart that shows you pretty straightforward way how to stage the UCS environment for getting the Docker up and running. So you rack and stack, and after rack and stack and cable everything in your data center, you bring up the UCS, do the initial configuration, and just configure ports. Any ports that you need to be configured for uplink, these are your Nexus switches, and then you create a required pools of MAC addresses, you need UUID pools, and IP management pools, things like that you configure, and the requirement for your VLAN. And any policy like quality of service that you need, and use templates. The V-NIC templates and the service profile templates is another cool thing within the UCS environment, which allows you to create a V-NIC profile for your servers. So what happened is, these are updating templates. If anything changes based on your requirements, so you have to make changes within the templates. So the entire changes just propagate all over to the server environment. And the same happens with the service profile. So if you have a service profile with different requirements for boot policy, let's say you have a requirement for the V-NICs, VLANs, and any other firmware policy that you have, power control policy, anything you have, it's part of the template. And that template is eventually creating a service profile, and it's bind to that template. So anytime you make any change, it just propagates to every single service profile you have. So once you bring a new blade into your environment, when you're scaling, you can quickly create a service profile from that template and attach it to the new server. So what we have done is we actually created a pool, server pool, inside the UCS environment, and that's each server pool has different characteristics. For example, controller needs different type of setup, DTR nodes need different type of setup, and worker nodes needs different type of setup. So we created 3 service profile templates, and we attached pools to that. So what happened, as soon as the blade comes in, you just tell that that particular blade belongs to that pool. That service profile template automatically kicks in and creates a service profile for you. So you can seamlessly scale your environment by using server pools. And once the service profiles are created, you apply them to the nodes. Then now the node is ready for the KVM console. You bring it up, apply the operating system, and then it's all. That's how the end state looks like. That's the UCS Manager console. Now the UCS Manager is also available with the newer releases on the GUI-based environment. This is the Java-based. So In this solution, we used, both the solution, we actually used 3 DTR nodes, 3 controller, and 4 UCP nodes. The only difference is the UCS solution is giving you the storage from the local disk, and the Flexpod is giving you from the backend ONTAP filers. So once you get all okay, everything is associated. You can see the servers where the service profile are associated, which means your entire environment has been configured for a provisioning operating system. That's the workflow for deploying Docker. Once you have the RHEL or any OS installed, these solutions are validated with RHEL. So any software releases that we have used has been tested and validated in our lab environment. So once the system is up, you can register as usual stuff. You update if you need to run any yum update or whatever you require. And the rest of the configuration we did is by using Ansible. So Ansible is providing automation and orchestration here. We set up one node, and the rest of it, we actually created host groups to apply the different kind of configuration. For example, GTR needs a little bit of different configuration, controller needs different, so the UCP worker nodes needs different configuration. So that's how we identify within the host groups. And let's say you want to set up NTP in the controller nodes, so we actually use Ansible to deploy NTP and run the service in the controller, UCP controller. In the same way, we actually configured a device mapper in direct LVM mode. So pretty much everything like installing UCP licenses, configuring NTP, installing Docker engine, it's all done by Ansible. So once it's all done, and then you can add nodes into different kind of roles, like you can add nodes to the controller, you can add nodes to the UCP cluster, you verify everything is working by running through Ansible commands. You can run Docker PS and commands to verify everything is up and running. And you can select one of the UCP nodes to install DTR, and the same node can be used to join the other nodes for the DTR using Ansible. And that's how the end state looks like once it's all done. You have a manager, which is one of the managers acting as a leader, 3 managers, and the workers, and the DTR roles. Here I'm only going to talk about what we have actually done in order to integrate Contiv. We already had a Contiv discussion, a pretty deep discussion around it. So it's going to be just how we set it up in UCS environment, and some slides is going to talk about how we tested it. It's like you can take it as a part demo, sort of how we are trying to test things out within the UCS environment. So every host we set up which is going to participate as a worker node is going to have a V-NIC that is going to carry the VLANs that is required for the Contiv. It's L2 VLAN mode, and we used V-NIC failover. So you can see that we mapped the ETH1 with the Fabric B with the enable failover. So which means that if Fabric B goes offline for any reason, it could be a firmware upgrade. Even if the firmware upgrade happens, if the Fabric B reboots, that V-NIC will be mapped to the second available path, would be Fabric A, and all the MAC address will be learned to the Fabric A. Then we pre-provision all the VLANs that we are going to use, just like the range which we're going to see in the next slide, pre-provision and attach those VLAN with that V-NIC. So and repeat the same step for all the nodes that are going to be participating as a worker nodes. And this is the service profile template. If you create a template, and if you have created, for example, 4 service profile or 100 service profile out of that template, if your VLAN range requirement changes over time, so you just go in, make a change in that template, add more VLAN, it will be propagated to every single V-NIC, every single V-NIC of every single node that you are going to use for a worker node. Or even you want to change it to map to Fabric A and then fail over to B, again, anything that you want to do. So after that, we ran some tests after deploying, of course, there are a lot of steps, deploying Docker, deploying Contiv and everything. Then we ran some commands, netcarol global set fabric mode default, and we gave the VLAN range. This range is already pre-provisioned, as I mentioned in the previous slide. And then we created a network by giving a subnet and a tag in cap VLAN. And after that, it's just inspect command, and we actually also created some policies just to see how the policies are working, and we already talked in much more detail about the policy groups. Once it's all done, we verify that our DB group has been created, our network has been created, and then we provision containers out of it. 2 containers, 1 DB, 1 web. Again, it's a verification command, trying to see if it has been created well. We can see that. And then we try to grab the IP addresses that has been assigned to these 2 containers by running a DB docker inspect command. And here, we got into these 2 containers. Here we are doing a different test, trying to see the MAC address learning within the fabric. So you can see that we got into both the containers by running docker exec commands, and we captured the hardware address, the MAC address of the interface that is actually providing the overall networking, and that is actually eventually mapped with the V-NIC we just talked about, and all the VLANs are already provisioned. And both the MAC addresses, after getting into those containers, you of course need to run some command like ping or something, either together or internally. There is local loopback type ping. And as soon as you do that, when you get into the Nexus Fabric Interconnect in NX OS mode, you run the show MAC address table, you will see that the MAC address has been learned. So it's L2 switching happening already. So any layer 2 switching pretty much locally happen on the fabric level. Here I'm going to talk about any questions so far, because I just concluded the configuration portion of it, how I'm going to talk about the backend storage for the Flexpod. Any question about the UCS?
I'd like to have one, but...
Okay, that's good. For the backend Flexpod storage, this is the configuration I'm showing here is AFF 8040. Here, boot disk is also provided by the filer. It's FC, FCOE based Linux boot. So the LUNs you can give 60 gig, which is recommended. Up to you, you can give more. And we also created another volume, 30 gig. 300 gig volume for configuring it as a device mapper for the Docker volume. If you want to use the NDVP plugin, then actually you have to create the NFS-based storage backend. You have to configure that. And so if you look at it here, we actually have a Docker LUN and GTR NFS LUN, which is NFS LUN. You can give it a like 3 terabyte or 4 terabyte, a big LUN that you can mount it to every DTR node. And here you have a Linux boot, which is providing you a disk, and that's a 300 gig Docker LUN. But here we have actually configured another NFS-based backend, which is actually being used by the volume plugin. So all the Docker volume gets provisioned here. So it's showing up, different sizes that you can give depending on your requirement. It actually works with any type of backend, SolidFire, E-Series, FAS, AFF. It's a unified plugin for every backend. And you can also import the existing volume. You can clone the volume. You can use the cloned volume back to, you can create a provision container after cloning the volume. So you can quickly provision dev test environment by doing that. That's a high-level configuration. So once your Docker environment is set up, you need to create a configuration file where you need to specify the management live, the user credential to get into the filer, and use the Docker plugin install command to set up the plugin. And in order to set up in the rest of the nodes, you can run the same command using Ansible to set up the plugin in the rest of the nodes. And it's available for NFS and iSCSI. You can specify these parameters. Currently, you can specify a size, space reserve, like thick or thin provisioning for that volume, any snapshot policy you have. If you want to give your volume more security, you can set up Unix permission for that while you're creating it. And these are the commands. You can create a Docker volume create. You give a plugin instance, name, and the size. Once the volume is created, you can actually use that volume to provision a container. These are the resources that you can go and visit. These are the links for our CVD. It gives you detailed step-by-step guide how to set up the Docker data center environment on-prem by using Cisco UCS.